angles detected in the S800. While here I do the same with turning those corrections off. And you see the drop for this case in resolution is less than a factor of 2. Of course, you like this spectrum more than this spectrum, but honestly, all you can do with this spectrum, you can do with this spectrum as well. So, does resolution matter? The nice thing of 24 magnesium is if you go to the higher energy part of the thing. So, here the same data set, again, sorted with a bad resolution. And I think I would have to spend a lot of time to convince you here's a gamma ray transition. Well, the same data set sorted with a good resolution, obviously, this will be a very fast discussion. There is a gamma ray transition. Now the question, of course, is, yeah, well, if I improve resolution with the same statistic is fine. So what is the case if I would need to sacrifice half of the gamma yield in this experiment to get this resolution? Well, I simply sort half of the data set. And I think this is pretty much more convincing here than here. From this we learn, from this example, double the efficiency is not equivalent, in this case, of improving the resolution by a factor of 2. Well, if I only take a quarter of the statistics compared to that, well, I do not know, it's easier to convince you with this guy or with this guy. But nevertheless, this is a thing we have to consider. So, I come to my summary, conclusion, and discussion. And the first point I think we are clear. If we use GRETINA, somehow like Sega, simply we use a Sega standard target and we make a Sega standard-like experiment now with GRETINA, then we still have an in-beam resolution improvement of approximately a factor of 2, but we really need to remind ourselves that we are limited by GRETINA's in-beam resolution at most angles by the target thickness or the velocity uncertainty. So that means if we plan such an experiment, we have to do a careful balancing between the target thickness, which of course is the gamma yield you can expect, and the in-beam resolution. Of course, GRETINA in this mode will benefit from all the other gains, so the higher efficiency and the much better peak to total. Now the question is, can we boost the gain in GRETINA by smarter experiments? So, and the first thing we can think about is gamma-gamma coincidences. If we remember the good old times in Einstein's physics, there were those figure of merit, or what is the gain, simply the words resolving power and fold. What is the gain in improvement if you improve your resolution? And for the gamma-gamma coincidence, all the gains will be squared. For example, you make a gamma-gamma experiment, you sacrifice 50% of your yield to improving your resolution, let's say by a factor of 3, the gain is 10, 1 order of magnitude. Another thing which is very important, we get a huge win by the better peak to total. Because if you calculate what does it mean, even improving a peak to total from 0.2, what actually Sega is, to 0.5, well, it's not a factor of 2. Essentially it means you remove 75% of your Compton background to get those improvements, which is nice for single spectra, which is essential for gamma-gamma coincidence spectra in terms of background. Another thing is what we already discussed a little bit, polarization measurements. Here's my third opinion to that. Polarization measurements. There is also gain involved by a squared number, the polarization sensitivity. The polarization sensitivity, I guess, for a GRETINA detector is at least a factor of 3 to 4 higher than for the Sega detector, which means simply we have to square the thing order of magnitude. It's nice. The question is if we find experimental case where it's really helpful, because if you do, for example, knockout experiments, well, then you probe the orbitals directly in the S800, for that you know the parity. On the other hand, if you make some kind of secondary fragmentation experiments, well, this is then the way to get parity informations. Another point might be angular distribution correlation. Here first, I admit I'm not an expert in this at all, but what I have learned for the fast beam application, the problem is that you want to couple forward angles, which is not the case in really extreme forward angles. I mean something around 20 degrees, which you don't do with Sega, which you don't do with GRETINA. But here I hope that we have experts who may look into that in more detail and have maybe some good ideas. I don't know. Okay, thank you.